Assalamualaikum warahmatullahi wabarakatuh, everybody. Welcome to another video of CC221 algorithms. Today this is an extra video on time complexity because we didn't discuss problems of time complexity in details, so I've decided to create another video on just the problems of time complexity itself. And let me start with the bad news that you have to bear with this Hebrew handwriting of mine. This is only for me, really. Only I understand this. I don't know if you're understanding this. I'll try to read it out, and the rest you have to imagine it, because there's no way, You're just typing all this stuff is just too much work. Okay. So these are formulas of counting time complexity. In case you're wondering what on earth are this, we count T of n time complexity. We count this, and we have a best case scenario and we have a worst case scenario, and we have big O, theta, omega. If you don't know these things, it's good to watch the first video, or you can just say the previous video, and then you'll get an idea. And there's a little example of finding T of n, but here we'll kind of discuss about that problem solving itself only. So let's get started, and let me pick a good color this time. It's easy, so let's just pick green. Okay, so we're starting with a for loop, and we're discussing about for loops. Okay, don't look below, just look from above, go with the flow. So here we have in one, we have a for loop which is simple as it seems. Normal implementation, no problems, no complications, nothing. So it will be order of n, so simple as this. Because the loop will run n times, so it will run 1. If the n is equal to 10, then it will run 10 times. If n is equal to 20, it will run 20 times. So it's just of order of n. Next, now let's make it complicated. It will not run n times if the increment is not 1. What if the increment is 3? Increment is 3. That means it will not, because when it's n is equal to 0, and then after the loop goes once, I becomes 3. That kind of changes things, because if n is equal to 10, then 3, 6, 9, and you're done. 12 is not smaller than 10. That means the loop will only run 3 or 4 times. It's actually 3 times, because 0 it was already there, so it will be first for it. Let's do tracing. So first, when it's 0, the loop will run and it becomes 3, and then the loop will run for the second time, it becomes 6, and the loop will run for the third time, it becomes 9, and the loop will run for the fourth time when it becomes 12, and that's when the problem occurs. Oh yeah, it does run 4 times. Anyways, so that's the problem. Now how do we count this? Easy. You find this. And where did the 0 come from? It came from here, in case you're wondering. 3 is this is the base for how much you're adding, and n is the part over here. No matter how complicated it gets, if it was z by p, I equal to z by p instead of plus 3, then you would have wrote n minus there's 0 there, so it's 0, and you would have wrote z by p, or you can just write p and minus 0. Just like that. Okay, I don't think we'll face that much complication, but still keep this formula in mind. And if you do decrement, it's the same old thing, because it will go from 10 to 0, so that's also order of n. Now here's something new. For I equal to 1, and it's I multiplied twice, so for the first time the loop runs, it's 1, and you get what do you get? You get 2, and then I becomes 2, you get 4, and then it becomes 4, you get 8, and then when it becomes 8, you get 16. So it is 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. You can say up to 2 to the power k. So if you run out this and try to find O of n, you eventually get up getting log of 2n. If you still have questions about this, how on earth do we get this, please feel free to ask in the comment section below. I'll help you out with this. I don't think you will face a problem with this, but if you still do, let me know. And you just get 2 to the power k, you put it equal to n, and then you get this log 2n, which can also be written as log n simply. Okay, now what if it's 5 times? Okay, no problem, log 5n. It's the same old log. Okay, how about if I divide it instead of multiplying? It's the same old thing, just like between these two. So it will still be log 2n. Now how do I use these formulas? Look at this example over here. We have a for loop which starts from I equal to 0 and goes up to n, and it's having a normal increment, but there is a new for loop inside it. Note it's inside it. Had it been outside, both of them would be order of n and order of themselves, and then you just add them. But this is not the case over here. It's a nested loop. It's a CSE 111 fact. It's a nested loop, which you have multiple loops in one, so you have that. So we need to consider both of them together because each are dependent on each other. So in this case you have this a normal loop which will give you order of n, similar to this one, and over here you also have a loop which is not normal but it's fine with the category like this one. So first of all, they are different by themselves. For this n, they will go order of n times, but this one will exclusively go log 2n times more, right? Because this one is log 2n itself, and then you have this O of n, so you get O of n into log 2n. So you get O of n into O of n into log 2n, which can also be written as O of n into log 2n, and eventually that will be your answer, because constant into constant would be that same constant. So I didn't discuss in that much detail because we spent some time in the previous one, but still I thought why not give it a try. There's one more thing I need to show you. Okay, it's fine to show you here. This is the Google Drive folder, and you will find the notes I create myself on this one. My notes, that means these are mine, so you can download them, print them, whatever, if you need them, that is. And if you want lectures lab, visit the other folders. Anyways, the thing I wanted to show you is those are kind of intros or trailers to my next videos. There are two hot topics which we'll be discussing very soon. One is sorting, say hello to my Hebrew handwriting, and the other is search. Now I don't know why I'm doing this, but I have decided to just discuss those different types of sort and search in this video. Just discuss how they work and their time complexity. The main thing is time complexity. So what are searches? You have sorting, 3 types of sorting that we are interested in this course. For now, heap, quick, and merge. Okay, these 3 are the ones we are interested in for now. Heap is a kind of tree sort. You use heapify and max heap to do this. What max heap is, it's kind of like a tree that we did in 2.0. So you create a tree, and max heap will have a structure like this. It will have 9 over here, 8 over here, and 7 over here, and then it could have 1, 2, 3, 4 over here, something like this. Okay, so it has its own kind. Quicksort works differently. Quicksort has a thing called pivot or pivot, whatever you call it, which is kind of thing we assume within the array, and then we do a quicksort of the left part, and then we do the quicksort of the right part, which is kind of similar to binary search, but it's sorting. And then you have merge sort, where you divide the whole array, divide and conquer system, divide and conquer. So where you divide the whole system into separate segments, and then sort those small segments and join them, and join again and then sort them, and join again and then sort them, and finally you have the whole array and then you have sorted them. So what's the time complexity of each? Both of, actually all three have a common case, which is O of n log n. Now why is that? Log n suggests there is matter of incrementation, right? And you, since all of them are recursives, this is a must. And why n times? Because we don't know how many times the recursion will occur. Depends on the size of the array, and any other constant is removed. So it's common for all three. However, we have a little complication in quicksort. For quicksort, this is the average case. So it's A V G. Just imagine I wrote AVG. It's not even Hebrew now. It's something alien language. But the worst case of quicksort, since you are doing the sorting of left ones and right ones, so there is a fact of double sorting, and not to mention you do a primary sorting, you have a worst case of O of n squared, which is pretty bad. You see, n squared is pretty much bigger than this. So quicksort, even though it's quick, its worst case can be horrible. Otherwise, all of them kind of have some of the same complexity. So that's all for sorting. And then you also have two kinds of search that we're interested in: linear search and binary search. Linear search, you just work like a dictionary. You just, go from I equal to 0 up to n, keep searching until you find it. Straightforward, the easy way. So it has a complexity of order of n. You can understand that if it's in the last element is the item you're looking for, then it's order of n. Binary, even though it's great, but it needs a sorted array, otherwise this won't work. So binary needs a sorted array. Keep that in mind, which has a quicksort, best case of log 2n plus 1, and you can float this one. In case you're wondering what floor is, I'll tell you, even though it's a 330 stuff, but I'll still tell you. And a worst case of sale are the same thing, So floor is 19.7. If you float this, it becomes 19. And why am I writing 7? Sorry. If you float it, it becomes 19. If you sale it, it becomes 20. That's the idea of float and sale. So binary search is pretty quick, because if you have 100 items, then a linear search will give you an average of 50.5. However, a binary will only give you an average of 7.7, something like that, which is a huge difference. But you have to keep in mind that binary requires a sorted array. So this is only applicable if both of them are sorted. Then linear will require 50.5 of average, and this will give you 7.7. Huge difference between them, and it becomes bigger if your n increases. So that's all for time complexity, guys. If you still have problems or questions you want to ask, you can ask here or maybe mail. And also all the notes that you see over here will be found in my notes. The ones I create will be found over here, but if you are interested in lecture slides and something, you can check the other folders. Thank you for watching and happy surviving.